Hi, Ty from Groovy Entertainment. Today we got a book on tape to play for you. Today book is Sun for 1985. So let's get started.
Sun. Life on Earth would be impossible without the great golden ball we call the sun. The sun gives us energy in the form of light and heat. It lights up the day and it warms up the air. It supplies the energy that makes life possible. The heat energy from the sun keeps the waters on our planet from freezing into a massive block of ice. Without the warmth of the sun, the Earth would be a frozen wasteland. But the sun never stops sending out its energy. The energy of sunlight is passed along through something called the food chain. The food chain starts with green plants. They use the energy of sunlight to change water and carbon dioxide into food so they can grow. When animals eat the plants for food, the energy is passed along. When those animals are eaten by other animals, the energy is passed along again. People eat both plants and animals. The energy we get from eating meats and vegetables originally came from the sun. This huge golden globe, the sun, is the center of the solar system. In fact, the word solar comes from the Latin word for sun. The solar system is made up of the sun, the 9 planets, their moons, the asteroids, meteoroids, and comets. Earth is one of the planets. All of these bodies travel around the sun in paths called orbits, and as they travel, they get heat and light from the sun. The powerful pull of the sun's gravity keeps the planets in their orbits. It keeps the planets from flying off into space the same way Earth's gravity keeps us from flying off our planet. The sun is so large that you could put 1,000,000 Earths into it and still have room for many more. It's hard to imagine anything that big. It's also hard to imagine anything as hot as the sun is. If a bar of solid steel were put on the surface of the sun, it would instantly turn to a gas, just the way boiling water changes from a liquid to a gas on Earth. And that's only on the sun's surface. At the center of the sun, the temperature is millions of degrees hotter than at the surface. The sun is a huge ball of swirling gas. It is mostly hydrogen gas and helium gas. Gold, iron, and all the other elements that are found on Earth are also present in the sun, but the sun's heat keeps them in the form of gases. These gases press incredibly hard toward the center of the sun. This pressure causes tremendous heat. The heat and pressure make the atoms in the sun's center combine or fuse. This fusion of atoms causes a huge nuclear reaction, like the explosion of millions of hydrogen bombs giving off great amounts of heat and light. The sun's surface is a place of violent activities called solar storms. These storms include flares, prominences, and sunspots. Sunspots appear as dark spots on the surface of the sun. They are caused when lines of magnetic force cut through the sun's surface. This makes that area of surface drop in temperature, and it does not shine as brightly. Over a period of 11 years, the number of sunspots changes from only a few to about 100. This is called the 11-year sunspot cycle. Sometimes giant flames shoot up from the sun's surface. These flames are called prominences. They are really sheets of hot, glowing gases. The gases in prominences never stop moving. They follow a great curved path that goes up, around, and back into the sun. Some prominences last a few days, others last as long as a few months. Sometimes electrified gas particles shoot out of the sun. These are called solar flares. Solar flares are smaller than prominences and usually last only a few minutes. One of the largest solar flares ever seen lasted 40 minutes. The sun also gives off a steady flow of atomic particles called the solar wind. When it passes the Earth, The solar wind is traveling at a speed of more than 1,000,000 miles, or around 1.5 million kilometers an hour. It contains an enormous amount of energy. In a way, the sun is a great energy machine. Day after day it bathes Earth with life-giving rays of light and heat. We see the light rays. We feel the heat, or infrared rays. But there are other kinds of radiation coming from the sun, too. These include ultraviolet rays, X-rays, gamma rays, cosmic rays, and radio waves. Ultraviolet rays cause sunburn, but they do good things for the body, too. Small amounts of ultraviolet rays help our bodies make vitamin D, which we need in order to build strong bones and teeth. Earth does not receive all of the ultraviolet rays the sun sends out. Many of these rays are screened out by our atmosphere. The atmosphere also shields us from other powerful rays from the sun. These are X-rays, gamma rays, and cosmic rays. Some of the radio waves given off by the sun are also blocked by our atmosphere. But some of the shorter radio waves do get through. Scientists are learning more about the sun by studying these solar radio waves. When sunlight reaches our atmosphere, it causes weather. The sun warms the air in our atmosphere. This warm air rises. Cooler air sinks and rushes to fill the space left by the warm air. The movement of these masses of air is called wind. The sun also warms the water in lakes, rivers, and oceans. This warmed water on the surface turns into vapor and rises into the air. Later, the vapor falls back to Earth as rain or snow. The winds, the rain, and the snow are all elements of our weather, and all are caused by the sun. The sun affects Earth's ocean tides, too, but not as much as the moon does. That is because the sun is much farther away from the Earth than the moon. The sun is about 93 million miles away, or about 150 million kilometers. That's roughly the same distance as 400 trips from Earth to the moon. Even though the distance from Earth to the sun is large, it's tiny compared to the distance from Earth to all the other stars in our galaxy. A galaxy is a huge group of millions and millions of stars. Our sun is one of them. It is near the edge of the Milky Way galaxy. How did the sun come to be? Billions of years ago, scientists believe, there was an enormous swirling cloud of gases. As the gases swirled in space, they were drawn together. The pressure and heat grew and grew. Then nuclear reactions began, and the result was the sun. That was more than 4.5 billion years ago. People have always been curious about the sun. Some have even worshipped it. In many ancient civilizations, the sun was called a god or goddess. To the ancient Greeks, the sun was Apollo, a god who rode across the sky in a golden chariot. To the ancient Egyptians, it was Ra, chief of all the gods and goddesses. When there was an eclipse of the sun, people of the past thought that the gods were angry at them. Of course, today we know that a solar eclipse happens when the moon passes directly between Earth and the sun, and that for a brief time the moon blocks the sun from our view. The ancient Egyptians worked out very accurate calendars based on the sun. Long ago, people used the sun to tell time and to find their way while traveling on land and sea. They knew that the sun rose in the morning in the east and set in the evening in the west, and they knew that the sun was in the southern part of the sky at midday. Just like the people of the past, we can use the sun as a clock, a calendar, and a compass. But now we are beginning to find new and exciting ways to use the energy of the sun. Many homes already have special equipment that captures the sun's energy and uses it to provide heat or hot water. Solar furnaces concentrate the sun's rays and create temperatures that are hot enough to melt steel in a minute. And solar cells, or solar batteries, use sunlight to produce electricity for spacecraft and artificial satellites. Today, we are searching for more economical ways to gather solar energy and put it to practical use. Who knows what the future will bring? Perhaps, in years to come, all our energy needs will be met with energy from that blazing ball of gas we call the sun.
So, that was The Sun from 1985. So if you like, subscribe, share, and comment, and have a groovy day. And our next book will be Moon.